Hello, welcome. This is the start of Unit 12. So before we can get into solids and volume, we have to do a little bit of an area review first. So we're reviewing areas of triangles and squares, a little bit of circles in there, and then we can use this information to jump into where we need to go to from here. Just one thing that you'll notice as we're doing some of these examples is that you have to sometimes use information that we learned in previous chapters to be able to get all the information that you need to solve some of these problems. So you'll see what I mean by that in a little bit. So first of all, the formula for area of a triangle is 1/2 times the base times the height, or some people prefer to do that as a fraction, which is base times the height and then divide by 2. You will get the same result either way. If you look at this note here, it's very important. Most people kind of, when they think of doing area of a triangle, they kind of picture a right triangle. But the truth is, the formula for area of a triangle works in any kind of triangle. You just have to remember that the base can be any one of the sides. Okay? The height is a perpendicular side or segment drawn to the base. So if you look here, for this acute triangle, I'm going to use this side as the base, so I would use the altitude drawn to that side as my height. If I chose to use this side here as my base, then I would go to this vertex here and draw that altitude. That would be the height, which is kind of what you see in this obtuse triangle here. And then, of course, in a right triangle, suppose I want to use this bottom side as my base. Well, in this case, the perpendicular drawn to the base is actually one of the sides of the triangle, so that can happen as well. Sometimes your height is one of the sides of the triangle, and sometimes it isn't. So here's a few examples. If you need to pause it and you want to write everything down first before you hear the explanation, that's fine. Okay? So look at example 1. I have all 3 sides measured, but I only have one perpendicular drawn to one of the sides. I have this altitude here, this 4 inches here drawn to this bottom side. So I'm going to use this as my base and this as my height. And I'm going to ignore the 5 and the 9 in example 1. So I do base times height, all divided by 2. That's 44 divided by 2 is 22. And don't forget with area that it's units squared. So since these side lengths are measured in units, our area is in units squared. In example 2, we have to know that even though they gave me 2 sides measured, I'm going to use the 15 because that one has the perpendicular drawn to it, the 3. So my area would be 15 times 3, that's base times height, divided by 2, and that will equal the area. For 3, you are supposed to remember special right triangles. This is a 45, 45, 90 triangle, an isosceles right triangle. So if the hypotenuse is 3 root 2 feet long, you have to divide that by root 2 to get the 2 congruent legs, which is 3 and 3. Now, the 3 and the 3 here are the ones that are perpendicular. So I'm going to use one of them as my base, and the other one's going to be the height, and it doesn't matter in this case because they're both 3. I'm going to multiply those and divide by 2 to get the area. So keep in mind, sometimes we have to do things like this, special right triangles or trig or whatever, to get the side lengths that we need to be able to calculate the area. This is where it's a little different than maybe what you've done before when you've seen these just triangle calculations where all the information is given to you. Same with example 4. This is a 30, 60, 90 triangle. So they gave me the short leg is 7. So that means the long leg is going to be 7 root 3. These 2 sides are perpendicular, so I'm going to use one as the base and one as the height. So I go 7 root 3 times 7. That's 49 root 3. Divide that by 2. And I get this. If you're doing this in your calculator, no matter what calculator you have, if you just type in 49 root 3, enter, divide 2, enter, and then you round 2 decimal places, you'll get what I have. And this, remember, means approximately equal to because I rounded. In example 5, excuse me, I used trigs. Remember SOHCAHTOA. They gave me this angle and a right triangle, and then they gave me one side. So since these are the 2 sides that are perpendicular, those are the 2 sides that I need to calculate the area of the triangle. So I need to figure this side out. So if I trace my angle 61 here, 61-degree angle, this is side that I need is the opposite, and the side that they gave me is the adjacent. So that's this part of SOHCAHTOA, that's tangent. So I'm going to do the tangent of 61 equals x over 5. We multiply by 5. This is our answer for x. So let's say I make that the base, the 5 tangent 61, then 5 would be the height. So I'm going to do this times this, and you can just, in your calculator, you could hit 5 tangent 61, enter, times 5, enter, and then divide 2, enter, and you'll get the area, this time in meters squared. And then for example 6, I have a right triangle and I have two sides and not the third. And this third side that's missing here, this x that I called it, that's the one that I need because I need the two that are perpendicular for the area calculation. So since I have two sides of a right triangle and I need to know the third, I just did the Pythagorean theorem. So I did x squared plus 2 root 2 squared, that quantity squared, equals the quantity 7 root 2 squared. When you're typing this in the calculator, you have to make sure you have these parentheses here before you square. And if you do, it will look like this. So I subtract 8. How do I go from x squared to x? That's a square root. Now normally in algebra, when you go from x squared to x, you do that square root, you have to put the plus or minus here in front of the square root of 90. Except we're dealing with the side length of a triangle, which has to be positive. So I just call x square root of 90. So that's the base, let's call it. So the 2 root 2 would be the height. So I multiply those, and then I divide by 2. I get root 180. This is me over here reducing the square root, reducing the radical by factoring out a perfect square. Or if you're just going to do the decimal calculation, you could just type square root of 180 into your calculator, and you would get this. The way that I got the 180, by the way, is this root 90 times root 2 is root 180. Now I have to take the root 180 and I have to multiply it by 2, and then I have to divide by 2. So those cancel out. So that's where I got it. Now, moving along. We actually have an area, so base times height over 2. That works for any triangle. But there's also a specific area formula that you can use that only works for equilateral triangles. So you might think an equilateral triangle is a triangle. Why would I want to use a whole new formula when I can just do base times height over 2? We'll look at example 7, for example. We have one side length listed, but they didn't give us any information, and they didn't give us a perpendicular drawn to that side. So I have the base, but I don't have height, so I can't do base times height divided by 2. But if you look at these markings, it's an equilateral triangle. So when I have an equilateral triangle, I can use this formula, which says the area of an equilateral triangle equals the square root of 3 over 4 times s squared. In this case, s is the side length of that equilateral triangle. So in example 7, s is 10. So I'm going to do root 3 over 4. That fraction times, what is the side? 10 squared. So I square this first. That's 100. And then I'm going to multiply across. It's a fraction times fraction. So what's root 3 times 100? It's 100 root 3. What's 4 times 1? 4. Now if you want, you can divide these and get 25 root 3. Or again, if you're going for decimals, you would just do 100 root 3, enter, divide 4, enter, and you should get the same decimal answer that I got. And here's just 2 more examples of that formula. Root 3 over 4 times, in this case, 3 squared. That's 9 root 3 over 4 divided. In this case, though, it's a little bit different because it has an x. So it's root 3 over 4 times 8x, that quantity squared. 8x quantity squared is 8x times 8x, which is 64x squared. So it's the square root of 3 over 4 times 64x squared. Well, that's 64 root 3x squared over 4. If I multiply across, I would just put the root 3 next to the x squared, right? And then 64 is divisible by 4. So that's where I got this number. Now you need to leave this x squared in your answer. So again, if you were doing decimals, you would just type 16 root 3, enter, into your calculator, and get that decimal. which is right here, and you put that next to the x squared. We don't know what x equals in this case, so we can't go any further with that. Again, all of the areas are units squared. Okay? The area of a square, if you recall, is just side squared. So these four sides are all congruent. It's a square. If this is 10 root 2, this is 10 root 2. So what's the area? This times this. That's just the quantity 10 root 2 squared. Use parentheses. If you use a calculator, you'll get 200. In this one, you have to do a special right triangle. So if you notice, this is a square. This right angle here is getting cut into a 45, 45. And then this is a right angle right here. If you remember from quads, this is because it's square. So this triangle here that's half of a square is a 45, 45, 90. Just like we did earlier, when we have the hypotenuse is 10 root 2, you divide by root 2 to get the side lengths, which are 10 and 10. So what's the area? 10 times 10, 100. Okay? And if you want to pause and write this down first, okay, these problems look a little bit harder than they actually are. Once you see it, you'll get the hang of it. So look at 12. Tells us find the area of the shaded part. So I just want these parts. So what I do is I write a little equation here that says the area of the shaded region, that's an S, it looks weird, area of the shaded region equals the area of the big square minus the area of the circle. Because if I started out with that square and I cut away the circle and threw it out, wouldn't I be left with the shaded region? Well, what's the area of the square? Well, that's 10 squared, side squared, so that's 100. What's the area of the circle? Well, if you recall, the area of the circle is pi r squared. So look at this square. So the circle is inscribed inside the square. If this side of the square is 10, wouldn't this imaginary line that I'm drawing right here, wouldn't this be 10 as well? And that line segment right there is called the diameter of the circle. So if the diameter is 10, the radius is 5, which I wrote right here, 5 centimeters. So what's the area of the circle? Pi times 5 squared. Well, that's 25 pi. So what's the area of the shaded region? It's going to be 100 minus 25 pi. So I could type this right into my calculator, hit enter, and I'll get this decimal. Over here, we're doing kind of the reverse of that. In this one, I have a square that's inscribed inside a circle. So I have to do the area of the shaded region is going to equal the area of the circle minus the area of the square. So if you look at this diagonal here, isn't this diagonal line of the square, isn't that the diameter of the circle? It's starting at one part of the circle, it's going through the middle, and landing in the circle. So if the diameter is 10, once again, the radius is 5. So what's the area of the circle? Pi times 5 squared, which is 25 pi. What is the area of the square? Well, look, we already said this triangle here, when you cut a square in half, you get a 45, 45, 90 triangle, an isosceles right triangle. So when you have the hypotenuse of a 45, 45, 90 triangle, remember you need to divide by root 2 to get the side. But you also recall from special right triangles in chapter 8 that we don't want this square root in the denominator of the fraction. So we multiply by root 2 over root 2, we get 10 root 2 over 2, which is 5 root 2. So the side of the square is 5 root 2. If this is 5 root 2, this is 5 root 2. So the area of the square is going to be the quantity 5 root 2 squared. Use the parentheses when you type it in the calculator, you'll get 50. So the shaded region is the circle minus the square. So the area of the shaded region is 25 pi minus 50. Type that in, hit enter, and don't forget units squared for area. So the area of a triangle is base times side over 2. The area of the equilateral triangle is root 3 over 4 times side squared. And then the area of the square is just side squared. Practice this, work through the homework, and then if you get this, you should be good going forward for the rest of the start of chapter 12.